Okay, so it's a minute past our scheduled time. We should probably start. Good afternoon, and thank you for joining these sessions where we will be very pleased to discuss best practices in solar engineering and procurement and construction. My name is Adele. I lead global business operations for Lightsource BP, and I am the chair of the Lifecycle Quality Workstream at SolarPower Europe. It's my pleasure to welcome you to this session today. And I'm very much looking forward to this presentation and discussions around the publication of our new EPC guidelines, which we are very keen to share with the wider industry and with yourselves today. So before we start the panel and the presentation sessions more in detail, a couple of housekeeping rules for the guests of this session. You will see our new slides popping up in the screen, but basically we're please asking you to maintain your video and your microphone off during the session. And should you have any questions, please, we will very much welcome your sessions for our Q&A at the end of the presentation and the panel. Please use the chat function in your team window. So before any further ado, just a quick reminder of how the session is going to be organized. We are going to have first a presentation of our new guidelines, our new EPC best practice guidelines that the Lifecycle Quality Workstream of SolarPower Europe has worked on from the beginning of this year. And this presentation will be followed by a debate and panel conversation with the four guests that you can see on the screen right now, but I will introduce them later. So I suppose without any further ado, I would leave the word to Ralph to talk us through the new EPC best practice guidelines.
Thank you, Adele. Okay, and thank you for the introduction. So can we pass on to the next slide, please? Hello, next slide, please.
Sorry, it looks like my colleague has a little, she will reshare the slide in a second. It wasn't changing. Sorry for the technical issue.
No problem.
It wouldn't be a Teams meeting without issues, isn't it?
Exactly.
Otherwise, it doesn't feel normal. That would be wrong. So I'll give this presentation on behalf of the three chairs and the coordinator of the lifecycle chairs and vice chairs, I should have said, of the lifecycle quality workstream. And the coordinator, this is Adele, who just started, Alden Lee, myself, and Benjamin Clarkey. Next, please. Okay, when we started this process a while back, we came more and more to the conclusion that the quality assurance needs to be done throughout the lifetime of the thing. And I just, okay, and also the industry has changed quite drastically over the last decades or so. We have for ages now a double-digit growth in the industry, which means we've moved from relatively small volumes of whatever component we're talking about to relatively large amounts of quantities which need to be quality assured throughout the entire life cycle, really. We also have seen a very significant cost reduction, which goes very often on the items which are, well, at least initially not seen to be too important, and that is largely looking at the quality in the longer term, because if I design a system, very often I look at the cost of the system and to put it on the ground. I very often do not consider what is happening after 5 years or even 10 years. And very often we call it haphazard stakeholder interaction. That means we have very often mismatched expectations. The EPC doesn't really agree with his definition of documentation, what he needs to receive from the preliminary design, or what he just needs to pass on to the final owners. The handovers are working, but very often there is a certain amount of friction which could be quite easily avoided with having a guideline what should be done here. And also sometimes the feedback from the field, what has gone wrong in previous systems, is not as good as it could be to the next preliminary design. So the circle isn't, or the loop isn't quite closed. And having looked at what the then O&M and asset management workforce of the SolarPower Europe has done, we thought there is a lack for the EPC side of things, which defines the very early stages of a project. And we started to set up the EPC best practice guidelines to address these issues. Next slide, please. Okay. So a year later, 100 pages, or closer to 140, if I remember correctly, pages full of words, and 14 chapters later, we're now very proud to present our EPC best practice guidelines version 1, and we're working currently on version 2 already. Next slide, please. We had experts and contributors from leading institutions and companies from all over Europe, mostly. Some of them are also acting worldwide. And you have a list here, which you can look at your leisure later on. So we move to the next slide, please. As I said before, we just really wanted to have closing the loop and just starting that actually we set the quality of a system is set at the very early stages. You cannot have a quality system if you do not consider quality right up front. And we said we have to start planning for quality, and that's in the engineering phase. In terms of a quality engineering side of things, that sets me the best possible quality I can achieve. Then I can make sure in the quality improvement, I can just really make sure that everything has been procured the way it should be and has been built the same way we've planned it. But overall, we will not improve much on what we've set in the EPC phase. In the construction phase, we all know that building projects have a tendency not to work out the way they're planned, and PV is not a different industry to anything else. Again, here it is very much about monitoring what has been done and making sure to tick all the boxes here. And then we move the project over to the commissioning and operational phase, again, where we control what has been done previously. Very important for us was that we plan it in the EPC phase. And so this is an absolute critical foundation for the quality we achieve in a system. And documentation and product specifications are critical for our entire quality process. Next slide, please. So we've added a fair number of chapters. It was 14 in the end, but also critical. It's not only about technical issues. Indeed, the technical issues are relatively small. They are there, but it's about things like health and safety, personnel training. What are the key performance indicators for an EPC, not individual people, but sort of what specifies a good EPC for us, what contractual frameworks we have, and what design and documentation lists do we have. Next slide, please. And with that, I think I've just went through my allocated 10 minutes. I thank you for listening, and I'm looking forward to any discussion we can have in the following. Back to Adele.
Okay, thank you very much, Ralph, for the presentation and for setting the scene for the upcoming conversation. So I'm very, very pleased to moderate this expert panel, and I'm very much looking forward to a lively debate among yourselves, guys, on what trends we are seeing, what we have learned in the last few years, and what do we see the upcoming challenges from an EPC perspective to hit this industry. So I would like, first of all, for each and every one of you to introduce yourselves, and then I will start grilling you. And hopefully the attendees of this session will also join me in grilling you with some questions. So please, if you're listening to this panel and you had any question, please do use the chat function, and we will ensure that we have a decent amount of Q&A at the end of the panel. So without further ado, I am going to call you out in alphabetical order. So Alden, do you want to go first and introduce yourself, please?
Okay, thank you. Yeah, I'm Lee. I'm working for ABO Wind. Before I was working for different module manufacturers, and in ABO Wind I'm responsible for procurement, logistics and quality, from audits to repair service, claim management, and so on. So these would be my areas.
Thank you, Alden. And Elena, your turn.
Hello, hi everyone. I'm Elena Kunkli. I'm a senior solar technical analyst in Statkraft, previously in SolarCentury, but as it was acquired by Statkraft now. And I lead the solar performance analysis team under the umbrella of asset management. And to note here that SolarCentury and now Statkraft are part of the prestigious research Horizon 2020 project, the Trust PV. So I might be mentioning it throughout our conversations.
Fantastic, thank you. Mariyana?
Hello from my side as well. I'm happy to be here today on behalf of Renergy, which is a company that's specialized in electrical design, especially in solar photovoltaic, but also complementary infrastructure like energy storage system and electric vehicle charging stations. I'm very happy to be contributing on behalf of Renergy to the solar power quality work stream. Yeah, thank you.
Thank you very much. And last but not least, Ralph.
Well, I had the first word. So my name is Ralph Gottschalk. I'm the head or director of the Fraunhofer CSP here in Halle. I have some 25 years or so experience in performance and quality management of photovoltaics. Earlier, a bit more in the academic point of view. And I think I'm here in the panel. I'm the odd one out because I'm largely as a researcher, and people tend to talk to me when things have gone horribly wrong. Before that, they trust in all the procedures and everything is fine. But if things go wrong, so I do apologize upfront that I have a very negative view sometimes about what is happening.
Okay, here we are starting already debating and we haven't even asked the first question. Right, so the first question I have in mind is very much opening up an old debate and an old dilemma. So I'd like to say that if I want to buy a new Gucci handbag, I need to pay for it. And I like to think that if I want a very efficient, resilient, and high-performing solar site, I need to pay for it. So what is the right balance between cost, quality? Is it true that only high cost results into good quality? What are we seeing this industry doing? And I will start with Alden, if that's okay, and then I'll go through each and every one of you on this one.
Yeah, sure, no problem. Yeah, balancing quality and cost. I would rather say that's what we don't do in ABO Wind. I rather would point it's a balancing of short-term cost versus long-term cost. So basically, it's about the total investment cost for the project. So if a company has a certain reputation, if a company and the management wants long-term success, then it's certainly better to invest earlier. And sometimes it might be that for certain projects you would need to audit a new supplier who's not that experienced. Then of course quality cost, this monitoring cost would increase, and then maybe the project doesn't make sense. But then better stop it in the beginning than have a burden later on. So quality is just one part of the total investment cost of the project. And that's how we view it. Having said this, of course, you still can make certainly some savings in quality. In our company, for example, we really try to work continuously with the same suppliers. So in that sense, you reduce quality costs, that you always have to audit the same suppliers, and smoothly, of course, you can find solutions quickly. You know how the other person and or companies are working, And also the supplier knows it's not only this business, it's also the next business. So the relationship to suppliers and the supplier management is certainly important. But then, of course, you also have to see how you can reduce other costs, like if you use the same bill of material from the same supplier, there's certainly less risk. And in fact, now I was talking even with Ralph about new kinds of tests, because it's quite standard that you always do this standard tests for certification, but maybe you can find out even earlier if there is an issue and you should dig deeper into it. But this is more to the future. So certainly we will develop more in quality and solar.
Okay, thank you, Alden. So I will probably switch to Mariyana now. Again, on the same kind of dilemma between quality and cost. How do they go together? Do they not? From an early designing perspective, how does this affect your decisions, for example, for your customers?
Yeah, this is the eternal fight, finding the quality at an affordable cost. And actually that's very important, because as we see the trends in the solar power industry, it's no longer focused on costs only. Now quality of the projects that are offered to lenders and are also going for public discussions and consultations, the quality needs to be high, so there is not really such a trade-off because between costs and quality, because quality pays off in the end. Just as Alden says, it's either short-term cost focus or long-term cost focus, and I think that the industry as a whole is moving in the long-term cost direction. So judging the cost of the projects in the long-term planning for long operational lifetime for every aspect of it. So I fully support Adon's view that the industry today needs to focus more on long-term costs and prepare quality projects. And from the design perspective, for example, in Renergy's experience, there is no two projects that can be judged that are similar to each other and can follow the same pathway. So it's very important to engage early on in the process a competent technical advisor to help judge the risks and optimize the costs that can be optimized and not pass on the costs that need to be considered in the design. So for example, if I may turn to the recent events, the flooding in Germany and Belgium, some studies cannot be overlooked, like the hydrological studies, for example, and it takes a competent technical advisor to judge which risks need to be considered and which can be mitigated early on as a cost. But in general, really, when you develop a project early on in the design, all costs needs to be considered.
Thank you, Mariyana. And Elena, for you then, are you also seeing from the stat graphs and previous solar century perspective that the affordable quality is becoming more and more mainstream, and perhaps investors and owners are focusing more on levelized cost of electricity as opposed to I'm assuming just focusing on the capex and the capex saving side of things?
I think we've been through a lot of lessons learned, and now it's not just focus on saving on capex and then paying it back in OPEX. That's just a false economy. So good thing we're moving towards quality and benchmarking between suppliers. So I agree with both previous speakers, but there's one point to mention here that sometimes, I mean, you know a supplier, you trust a supplier, yes, but if you do try and keep the competition high, this will drive the cost down and will increase quality. And we've seen that with different, for example, monitoring providers. you know how that is. So you try one, you try a second one, and then you see points where one can improve. They drive the competition high, and then you get a better product in the end. So yeah, benchmarking is part of our process, definitely in all of the chain of the project.
Thank you. So Ralph, I'm hoping you're gonna tell us some horror stories now, or
No.
some memory of somebody calling you because something went horribly wrong, despite looking at levelized costs of electricity, despite benchmarking different suppliers. I'm sure you have something for us, so very juicy. No name basis.
If you insist on it, I think most people have an issue with the polymeric backsheet of a certain type. At least we have a good 4 gigawatt of this particular type in the German market, which has only a limited lifetime of, shall we say, we can now argue if it is 5 years or 15 years, but it will fall apart badly. And it's only a matter of when it happens, not if it happens. And that is a typical example of why sometimes it's good to pay up front and not to pay afterwards. There was nothing untoward in this specific backsheet. It was tested and tested and tested. They paid everything and anything they could do for the tests, but they fell over because there wasn't a test for this particular failure mode. And that test didn't exist because it cost money and the material verification didn't happen. And that's sort of the loop. If you just saved maybe 100,000 euros in testing money and you have a couple of tens of millions of damage in the field, that's sort of the kind of thing where it could go wrong. But I don't think this is a standard. And really, this was nothing untoward. This was just simply bad luck. If you just try a new material, that can happen. But I think we have a little bit of the issue that who's paying for what in the industry. I think we have the design and the EPC who are charged to develop the cheapest possible product and sell it on. Then typically after 5 years, they're out. And quality issues, well, except for the infant mortality, really start to bite maybe from year 5 to 7 onwards, hopefully only. And then the EPC is more or less done with their responsibilities. And the person who takes on the system in the longer term very often is not who works with the EPC in the beginning. I think also alternative, similarly, Alden mentioned it, that we have a very, I would call it an over-reliance in the industry on the qualification tests, IEC certification tests here. Because if you look at the quality cycle of any product, you have sort of a design verification. And there you need to have very harsh tests. And you need to verify that everything has been done, that it meets your specifications, and we do that. When we then go into the building a system, we do any kind of cross checks, we use the same tests again. But really, this doesn't need to be the case, because here we only verify that everything has been done to its design, and we're not needing to recertify the modules in the field. And there's actually quite a big cost savings, which could come in, and also a time savings and a quality enhancement if we would just verify a higher percentage of the modules. So it goes both ways. I can see cheaper ways of doing a better quality assurance. And that was a positive message for me, rare.
Okay, so I was wondering who would have been the controversial one if I was asking the question instead of answering them. I suppose I got my answer from the first round. Actually, you pose a very interesting question. So who is paying for what in the industry? So I'm going to try to turn this around. If we look at the supply chain in particular, who do we think should pay for what? Alden, I'm picking on you first.
What was the question, please?
I'm rephrasing Ralph's question basically when he was controversially saying who actually is paying for what in this industry. So if you look at the supply chain specifically, who do you think is actually picking up the bill? do you feel like EPC contractors keep on being squeezed in the middle? Do you feel that the maturity of the industry has got to a place where actually owners are more comfortable in accruing additional costs for the good of an operational side that is effective and efficient?
Yeah, I mean, I would say the EPC company has to pay the bill, but that's clear. I mean, that's normal risk management. The question is always who is in a position really to minimize the risk. And here certainly it's our job as an EPC company to monitor all the suppliers, to go there even before ordering. And then also once we see they in general are able to build it in a good way, also to monitor the batches delivered. So an EPC company should have the capability to do this. And then, of course, the EPC company is even constructing, bringing it together, doing the design. All this quality issues comes together. And then, of course, it's the cost of the EPC company, but basically the problem of the investor who really wants to buy the power plant or who is asking for EPC services, because the question is, of course, for the investor to decide which EPC is doing a good job and which EPC sees rather the way to save here some margins, because problems will pop up 8 years later, 10 years later. And that's why I said in the beginning, it's really important that you have a management who has an interest in a long-term success of the company. If the management of the company might think they will leave or have the wrong incentives, there might be a risk. So here the company has to be set up in a way that the top management has an interest in the long-term success. And of course, a company with a certain reputation knows, even if they are not legally liable, if something happens in 8 years, it's certainly their responsibility and part of their reputation and brand value. So this has to be considered. I don't know about other ways, but that's basically the investor then who has to make the decision, which is certainly not only price.
So it's very interesting, no? Because so you raised this challenge on the supply chain, and Elena was quite rightly mentioning how you can benchmark different suppliers, whether it is a piece of equipment or a SCADA system and monitoring system, so a more software-based type of solution that will drive competition and potentially the cost down while maintaining a certain standard degree of quality. And Mariyana was mentioning how not one site is equal to another. So there is quite a lot of bespoke work that needs to be done for each and every one of these sites. So how do we, as an industry, go towards the path of standardization? Can we go toward the path of standardization from a design perspective, from a procurement perspective, whatever type of items we are procuring? And in a way, I'm going to go to Ralph later from a if you like, quality assurance perspective. But maybe I start with Elena first. Is there a way to standardization? Do you see your effort in benchmarking pushing towards that direction?
Sorry, I always lose my mouse. Yes. From our side, I can say there are, using that benchmarking technique, we pretty much lay out our specifications, how we want things to work, and what we want to have in the technical specification documents for the different suppliers, for example. I know from our perspective that we do it, for example, on a monitoring system, because our team is the one that's going to get data, and we need good quality of data to run our performance analysis. That's an example. And then we keep that consistent, and then go out and see who can actually comply with those requirements. So yeah, we keep our quality high. We don't do discounts there, and see who can supply those, who can comply with those specifications. Hope that answers your question.
Yes, it does. Let's see whether anybody in the audience has any follow-up for that later on. And Mariyana, how do you? I find it very interesting what you were mentioning about not a single site is the same. And I have been managing site for a good chunk of years of my career, and I would absolutely second the fact that I remember a number of troubled children, and they were all very troublesome for all very different reasons. But part of me is also wondering how will we able to scale and deploy the capacity that we need to deploy to support the journey towards net zero, not necessarily only in Europe, but even beyond, if we have to deal with such level of bespoke complexity for each and every one of our sites. So from your engineering perspective, how would you square the circle there?
The truth is that there is no easy answer to this. So it's a very complex a situation, and a lot of factors needs to be considered. So from my own perspective and personal opinion, so Renergy has like 15 gigawatts design all around the globe, and we have seen really outrageously different environments in which you need to design a project, even working with the same leading developer or EPC constructor. So there are really a lot of local and site-specific requirements that needs to be taken into the design and carried on in the O&M and operation of the site. So there is no easy answer to this question. I think that what I can give as an insight is it needs standardization is possible in the contractual framework, in your general approach to how to go to projects and how do you develop them. Finding local partners also helps a lot with indigenous knowledge, and working with experienced companies that have met with different conditions, different site, different requirements, and having like the experience built up over the years from errors and trials and so on, that also helps a lot, because the experience is something that you cannot overlook. It's something that built the industry and built the technical advances that have been made to optimize and reach this level that we are able to go to an industry that is affordable already and not having to be supported with any subsidies. And so
thank you, Mariyana. And I suppose probably the last question I have on this standardization point, and I'm going to be not very cautious, but I'm going to use the question that is in the chat as well, just to make Ralph's life more difficult. But I suppose from a supply chain perspective, and some from a, I would say, main components and panels in particular perspective, do we see consolidation and standardization in the industry, or do we see continuous technological changes and improvements that for sure are improvements, but might also be disruptive insofar the established practices of how to design a site, how to then install and deploy are in the market. So specifically, one of the questions that is being asked here by Marcus Vogt, hopefully I pronounce your name correctly, is why there are not yet norming and standardization on module sizes, for example, that will definitely generate cost improvements in the value chain. So maybe I go to Ralph first and then to Alden on this one, and maybe then we move a bit topic.
Okay, in terms of standardization, I should say I celebrate this year my 20th year on being part of the IEC Standards Committee. So maybe not the worst person to ask here. The discussion about standard sizes, that has been around for a long, long time, and everybody really is in favor for that. But the question is always, as long as you use my standard, standardization is brilliant, but anybody else's, it's difficult. I think in the last years, 2 years maybe, or 18 months, we've seen maybe the biggest diversification in for example, module dimensions, which is what we talked about, because we have different wafer sizes, different contact sizes. We have all of a sudden people start shingling, people start doing this, that, and the other. So there's a massive change in approaches of how to build the module. And that also has an effect on the sizes. And unfortunately, sizes are then only a couple of millimeters long, so you can't exchange one module for another in the field because, well, that's the way it is. And then you have to remount everything from scratch, which is not particularly helpful. So it would be good to have the standard, but getting the industry to agree on it, that needs to be the big idea. And I really don't see that happening at the moment. But then again, you also asked me for being a bit controversial. So I'll just throw you one again. It's worthwhile considering why we make our quality standards at the moment. And I know the gut response of most people will be, oh, to ensure the quality, but the standards are not made for that. They're made for making a product saleable. The quality is only a secondary concern, and it gives us the indication of being robust. There is a long list of standards which has been discussed, where we ended on the shortest, lowest cost denominator, well knowing that we have a standard which declares something as, shall we say, PID clear or free, and well knowing that we then put it into the field and we've just delayed the response a little bit, but we're not necessarily having excluded it. So there is still standardization would be good, but it's always difficult to achieve or what you standardize for. And the third point was maybe something I wanted to say for Elena. I think there's also the example she said about good quality data to monitoring it. There's also a lack of understanding why people need that. That goes throughout the entire value chain, because the number of discussions I had recently is that, oh, a sensor costs money, and so let's buy some artificial data which allows me to estimate the performance ratio anyway. Yeah, but what are you not getting? You can't do any quality control in your system anymore, but people don't understand. So a standard, more a practical standard, a guideline would be very good for that as well, yes.
Okay, so we'll let Elena maybe respond to that. You are kind of sidetracking my entire line of thought, Ralph, here. I had another couple of topics I wanted to cover before, but let's talk about data. Everyone talks about data and big data. Everyone says a lot about them. I have yet to find somebody who's actually being extremely successful in our industry at using that appropriate data to the full extent. So, Elena, I don't know if you want to follow up on Ralph's comments.
Yes. Yeah, we do many things. I don't even know where to start. From when you mentioned the reduced cost, for example, but not sacrifice quality, the first thing that came to my mind is, are we actually trying to reduce now the number of sensors on site, for example, the irradiance sensors on site, and go literally by what the IEC 61724 standards say, use, I don't know, 4 irradiance sensors for I think 100 megawatt peak site, for example, which is, I wouldn't go for that, but we always need to think about the peculiarities of the practicalities of a project before we look into. Sorry, I went back to point 1 now. I didn't mean to, but sidetrack you even more and then go down the chain again. But yeah, quality is very important, and we're seeing that now also in Trust PV, because we're doing, for example, KPI benchmarking across different partners, across different locations, across different technologies. If there's so many variations in how you treat quality, we don't have a reference point. We can't do that properly. So it is important. And then you go down to you thinking about proper accurate failure detection using whatever model you use, whether it's an empirical model or AI or whatever. Accuracy in input will give you accuracy in output. You can't avoid that. You can't make discounts indeed. I've seen some people in the audience will agree with me. I've seen at least one. So yeah, I agree with it. It's a bit disappointing to see that quality is actually second on that regard, but I think we're getting there, especially when we're talking about performance guarantees and then quality in design. Input and output data are very, very important because they might lead to unwanted penalties, and then you see people actually appreciating why data quality is important.
Okay, you guys are really putting a lot of new topics on the table. So quality in as an input and quality out as an output. So if we assume design is an input, then I'm coming to you first, Mariyana, on this. Then how critical is a solid, proper preliminary design, initial design, suitable engineering? How does that drive quality? And maybe then we talk about installation, Alden, with you once we have a decent preliminary design.
Yeah, I would say that it's essential because how you start is actually how you end up. Starting with the quality in mind from the very beginning and working up on your design before you come to the installation, so that every aspect important to the quality of the project is considered, determines basically the outcome. Because when it comes to installation and you're working with a certain design, there is only so much that you can do within the process. Some things may go wrong, but in general, having the design at the issue for construction stage prepared and done with quality in mind by experienced technical advisors is something that cannot be passed on if you want to look at a project that is working exactly as designed or close to it, at least. So yeah, I support Elena completely, that input of data, and also working with softwares and models with engineers that have been doing this for a long time and know what kind of inputs are important, for example, to put in the PVC simulation, how to generate the exact shading scene that is needed to produce a decent PR estimate. That is very important and cannot be passed on as an input and data. So I would fully agree that starting with quality in mind is determining actually your whole approach to the project realization, including procurement and then installation. So yeah, I think it's essential, and it's essential to consider every aspect possible, which is why the guidelines come very handy, in my opinion, because they set the framework of where to look if you have forgotten something to consider. Maybe not all of the best practices and requirements can be applicable in the case that you're looking at, but at least some of it you can consider, and it will come very handy as a starting point of when you're planning the quality of the whole life cycle of the project.
Basu, thank you very much. So I suppose I'll turn it around to Alden as an EPC contractor. So you're expected to a degree, work on the engineering, work your supply chain as hard as you possibly can, install with the highest possible quality, yet in an affordable manner. How do you make all of that work? Seems like you need some sort of magic.
Yeah, indeed, it's challenging, and here, yeah, I also want to emphasize it's not that you do the preliminary design and then you procure the products and then you build it. It's really a back and forth to optimize. For example, the question was regarding standardization of modules. We have indeed the problem that design team now cannot always design the optimal system, but may have to design an open system so that you can go either with this supplier or with that supplier. Because when thinking of quality, of course, it's nice. I make all these audits and then the company cannot provide the quality, the batch is refused, and then you have to have always, quality is always about having another option. You know, just be clear, and we make these quality controls, and suddenly you are not in the position to reject. That's bad. So you need an option, and if there is not enough standardization, you might not be able to do that. So that's also part of design, to make a design where you can have a second source. And yeah, now while we are not standardizing, I mean, actually the modules had been standardized, I would say, for quite some time. And then suddenly we had those changes to bigger cells from 156 to 158. And then last year they also introduced 166 millimeter cells. We were told actually that they will stay at least for 5 years in the market. And now we are told next year they will fade out. So if projects have a planning time of 2 to 3 years, that's of course a big challenge. But why did they do this? Because it saves basically money, and if you see the module manufacturers, quite often if you see their annual profits, it's about 1% of their turnover. So it's really, they are the ones, and that's why audits are important. I mean, 1%, you know, I mean, don't spend too much money where it's not seen, right? So it's dangerous, but that's why they try to reduce really very small amount of money and improve. And now we have the bigger challenge, because now the new modules will be with cells of 182 millimeter and 210 millimeter, and they behave differently, quite differently technically. So you need different inverters, you know, and it's different string. So it's a complete new system. And so in that sense, we are not really moving towards the standardization, but it's really, you can make even the module size quite similar, but because of those technical characteristics, it's not possible to replace these modules. And that's now really a problem, that now from an early stage on, you have to make a decision for which module you go. And then basically you also only can take a supplier of that kind of module as a substitute. So it's challenging, but what we can see is that still overall costs are decreasing. We are now in a strange time, because at the moment a lot is still theory. With the racks, for example, it's still manageable. It's more like the trackers. How can they work with longer modules? Of course they can do, but it's always a question of time. And this is really that nowadays, as an EPC, you try to bring together the module supplier with a rack or tracker supplier, see how they can optimize. It really should be optimized for a certain size of module. And if you have a long-term planning where each partner can see a benefit in the long run, then of course nobody is trying suddenly to make big prices. But if all can agree to competitive prices in the long run, then it can work out that you really still can make a profit. But it's also no secret that in solar, it's actually less that you make the money with the normal power plant or the construction. It's more like bigger size and more often being more efficient, then build it faster, capital control, and so on. So I'm basically, as you know from the name Wind, it's from wind. And of course, their technical understanding is that solar is easier, but because it's easier, there is more competition in it, and it's really that only the efficient companies can survive. And that's of course why we have this discussion that quality is so important, because in such an environment some companies might be too much thinking that you can save money, or you just think of this year and next year. And that's why it's really time for the quality guidelines to come up with, and I think especially the investors will be thankful to us that we show them what they can ask for.
Let's hope so. Let's hope they're not going to ask even more difficult questions. To be fair, we ask a few quite challenging questions in the publication already, so let's hope that that is going to be sufficient for the time being until the next version. But basically, you guys have talked about the challenges of standardization, the uniqueness of a lot of sites, the challenges coming from the supply chain, and I am very familiar with the challenge that Elena was describing around what does saving cost means if you put less sensors on site. I remember a time where I had to fight to have string level monitoring because nobody could really understand why I was so keen in having string level monitoring. I would have been happy to monitor my central inverter, and that was it. So and that was thankfully very many moons ago. But I suppose the data point is a pretty exciting one, no? Because we are seeing how we are trying to automate and digitalize the entire life cycle of the sites to an extent. And so I suppose linking the quality thought whenever we design a site and we oversee the construction of a site, and then how does the site behave in operations, and what is actually the efficiency and the performance of that site is a pretty hot topic at the moment, and data is clearly foundational in building this understanding and potentially automating also the way in which we design, develop, and manage sites long term. So I'll go to Elena first, and then to Ralph. But how do you guys see the digital representation of sites? How they can help us achieving even more quality still on an affordable basis?
I think in terms of, well, digitalization, it can be from very simple to very, very advanced. But even in a simple map of a site with a performance layer on top of it is already gives a lot of value, because you understand where your losses come from, and you understand whether there's any particular surroundings on the site that are causing this underperformance. So, for example, how I would say useful is if the handover, let's say, from EPC then to O&M, apart from all the documents, reports, or manuals, there's also a collection of a standardized, again, I'm afraid, extracted information of components or basic components on site, that is inverter and strings, for example, their geolocations, and a base map, which is what you need to enable a first layer of digitalization of your plant. We're able to use this information and then overlay the performance of the strings on top of this map. And actually this is twofold, because it gives O&M a very good idea of how the site performs and where it underperforms, and how much the losses are with our calculations. But it also gives feedback back to the design. So it's good, for example, to see what's the impact of the tree shading there, and can you take this back to design and see whether you had designed it correctly, or you underestimated the losses of that obstacle, or the shading, like Mariyana mentioned, for example, self-shading. Is it really that severe as was in the design? How can we improve then? How can we, if that's, I always like to have an improved version of PV-Syst and improved as actual, as built, sorry. With all this information from going back from analysis to design. So to me, it is a circle, and a map is a great visualization tool. And that's just my base map. Is easy enough to pass from EPC to O&M, but that comes with some caveats in terms of standardization of naming and labeling. As I understand it, and some softwares, let's say, are not able to go down to labeling strings because the naming structure has one extra level that is not able to be represented in design. So we're facing these things, but it's good that people understand the value of a map and then a digital twin and then a BIM over that. So there's much more effort in design and improving software to address those challenges in tagging and labeling components on system. And I haven't even mentioned modules yet, because if it's string monitoring, that for me, having strings, that's good. Now, if you want to go down to the more advanced digital twins with the modules and all the information from the thermal imaging, for example, and the power loss correlated to that thermal imaging, like many experts are doing in Trust PV right now, that's great. But even a basis of that is very, very, very valuable.
Thank you very much. So, Ralph, you are the academia of this forum. You
of course,
must
I
love
want
data.
More data, indeed. The more data I can get. No, I think this is also one of the weak points where we waste money. I think Elena said it very nicely. We need standardization of how to represent and what we represent. We have one digitization provider which throws data out in format A, which is not taken in by software B, so we have to pay an IT consultant to transfer everything. This doesn't sound very efficient to me. My second point would be PV systems are nothing but relatively large building projects in many ways. And in which building project are we happy with an as-planned digitalization? I think no building project will accept an as-planned final commissioning. We just always want to have the as-built, because we all know that the typical builder can be very creative when it comes to the interpretation of the building plans. In a very extreme case for a PV system, I have seen one builder mixing up north and south. So, okay, minor issue, but this is very extreme. But you will find, if you're 10 degrees out, which is not so uncommon again, you will find that all your performance monitoring is a bit skewed, and then you lose what you can find out about it. And then again, finally, why do we want to have the data? Why do we really want to look at it? Because at the end of the day, we want to reduce our O&M costs. We want to nobody is really so critically about it. If it is a beautiful monitoring, everybody wants to have cheaper monitoring. We want to have less alarms. We want to have certain problems we want to catch as early as possible, because if we don't catch them early enough, they leave something which is not recoverable. If we are too coarse in the data, coming back to your inverter, or I just know also transformer only monitoring, brilliant. You have no resolution if something goes wrong, and then you just realize, well, I was losing a lot of money on the system, but I don't know why. And if my data quality is too poor, I send out a lot of engineers fixing my data, my SCADA system. So again, it's savings on the one side and costing a lot on the other side, which I don't think would be good. So the standardization and also basic levels of monitoring and data quality would be really appreciated. And if that means 3 more sensors, that's fine, but in the long term, you save money with it.
Understood. Thank you, Ralph. So I think the audience is letting you guys off the hook quite easily because they're not asking very many questions. So I'm going to go through another topic still related to data and related a bit to performance as well. And this is pretty much how it is that we run performance analysis. We tend to think that a good quality project has a pretty decent PR and can consistently deliver that PR. So I think I'm gonna probably ask briefly to Alden, how do you tackle during your discussion with your customer, your negotiation, the overall PR topic? And then I'm aware that Elena has some interesting view of where we should aim as an industry, what our ambition for future performance analysis should be. So maybe we start with the two of you, and then I get Mariyana and Ralph as well to comment.
Yeah, I think there's there has to be certainly a commitment from the EPC because the EPC is building everything. The EPC is selecting the quality materials, but I would say it's really negotiated with the customer because everybody understands there are certain risks. So we have to see, let's say, the higher the performance guarantee, the higher the risk is, and that's where we have to find, let's say, also our sweet spot. But of course, in general, we agree and we use the calculation, and if the quality is okay, if the design is okay, then actually nothing happens. Of course, here and there there might be a problem during construction that you have to exchange a cable, but this can all be arranged. I think the bigger problem is really that you don't achieve the required ratio if there is a problem in the design. So this should be avoided, and that's why I would rather hand the answer over to the experts.
Okay, Elena, I suppose this is for you now, and then I'll get the other two panelists to comment a bit on the topic as well.
Yeah, I agree. Eventually, everything starts from the design, because that is what is going to define the PR, and that is what then is going to drive the guarantee and the negotiations. But I think PR as a performance guarantee is can be quite controversial. And it's smart in that it's quite simple and it has its merits. But as the sites become more and more complex, I think PR is starting to be less and less suitable for as a performance guarantee, or at least we should start considering other options like energy performance index. I'm afraid this goes back again to the accuracy of the design. So everything goes there. So the pressure's on you, Mariyana. But in general, the challenges we see, for example, in the short-term performance testing, like PAC, for example, you have 15 days to achieve a guarantee. So if you have increased, and that's the biggest problem, if you have increased inverter clipping and or grid limitation, then that's gonna, you can't actually use PR. So there are solutions like excluding those hours, but then that is going to skew your analysis. Whereas if you could actually use real data, put them back into your model, and then compare actual with expected, I guess you get a more objective a more objective metric already. And then there's the other thing is the forward kind of looking penalization when you don't achieve a PR at FAC, for example, you get charged for the next 18 years, and that can equate for a plant about 300 megawatts, and a deviation from guarantees as low as 0.3% can lead to 1 million or something. So that's crazy, because PR, if it's not corrected, it has its own problems we all know about. If it's temperature corrected, is better, but still is not enough, because you've got this oversizing of plants, for example, that's starting to become more and more of a problem, and especially at higher sizing ratios. So all I'm saying is PR is not going to disappear, but for very complex sites, it starts to become more unsuitable, and we should keep an open mind for using other performance metrics as well, and put more weight on the accuracy of the design, because that's going to, after all, that is defining the value of the project.
I wish we had some project finance banker in the audience to ask a couple of questions at this point. But so, Mariyana, it would seem that everything starts with you from the conversations that we had so far. So how much do you have in mind this type of performance assessment when you design a site? How much do your customers ask you to have that in mind during that phase?
How lucky for me that I'm not actually an engineer. But yes, in any case, everything starts with the design. This is my opinion, so I fully support this. Design is very important, and for sure, performance ratio is like a staple. It's established in the industry as quality KPI for a project. So I don't think that it's going to disappear soon, because especially when you go to financial institutions, PR is something that for them they're used to looking at it and judging the project and the income that will come from it at a later stage. So as I said before, it's very important how you produce your simulation, what inputs data you put into it, and the outcome that comes, whether it will be close to the actual work of the plant, or it will be underestimated, or in some cases overestimated. So data is very important. Important is also who makes the simulation and how the simulation is made. And if I may suggest, there is something called yield optimization study, which is overlooked for many projects, but it can give a lot of information at a very early stage at the conceptual design. So in this yield optimization study, basically the engineers are doing calculations and simulations with different parameters. What Alden mentions, that you need to have options. So you can design different options at a very early stage, simulate the results, and see what is the best parameters that you can put into the design. And this is an optimization that can be done very early stage when you have just the topography of the plant and the basic concept design. So I would recommend this study to everyone who wants to consider really good quality projects, because it can inform a lot of decisions, including on the supplier side, and what kind of equipment you will need and what options you will have for this specific site. So yeah, if I'm repeating myself, but really there is a lot of data that can be considered at a very early stage that can save a lot of costs and a lot of efforts actually at a later stage of the development of a project.
Thank you, Mariyana. And Ralph, what do you think of PR?
Well, it's a good number, but you run a little bit in danger of a competition. My PR is higher than yours kind of thing, which doesn't really help. I think we also close the loop a little bit to the data quality issues, which we discussed several times here. There is value of designing a lower PR plant because it has the potentially is cheaper. Potentially, if that is in the long term valuable, but there is the business model of doing that. That needn't be wrong. So if there are issues with it, I think the question is more, what do we do if we deviate from the predicted PR in the design stages? And there Mariyana said very nicely, we need to have at least, again, a data quality standard here. What is the standard of a design prediction? I mean, I can come up with any number I want in the design values. I've seen people, well, in PVSys going into PVSys and changing certain standard parameters to something which agrees with the financial predictions. Not that it had a lot to do with reality, but at least the project was working financially afterwards. And these kind of things, there is sort of good quality initial design, a reliable and robust initial design defines me the quality of the system. And then I think the test would be how well does the developed system in commissioning meet the design parameters, and PR is one of them, but by far not the only one. And I think there is a lot of other things which should be considered as well. And it goes back for me to the entire digital representation of the system. So even if I'm lucky and have a wonderful PR on the day I do my commissioning, be it PUC or FUC, then that's great, but that doesn't mean that the system is high quality. We need to go well beyond that, I would say.
Thank you, Ralph. Okay, I kind of covered all of the topics that I wanted to grill you about. There is one question in the chat that I'm going to read out aloud and is from Axel Gonard. And the question is whether you guys are investing or perhaps working with clustering analysis for PV projects. If you know what it is, that's quote unquote. So if you don't know what it is, then maybe I can ask Axel to just type in the chat a bit more of a description. But I think you're mute. Okay.
Is it some, do you mean spatial clustering or classification of different sections of the plant based on specific criteria? That's how I get the question.
So if Axel is still in, yes. Oh yes, he's saying yes. Okay,
then the answer is yes. But then it goes back to having for systems that have different terrains, for example, or slightly different orientations. Would like to have at least all sections be represented by an irradiance sensor, a reference cell, I'd say. And then, yes, you can do your clustering analysis, at least spatially based, which is and installation angles based, which is more accurate than using a blanket irradiance for all of your site, especially if your site is very big. So yes, we do invest, but it goes down to the number of sensors that you have and you can utilize for this study.
Is there any other of the panelists who would like to pick up on these questions, or Ralph, we know you would love the data. That's clear.
I could comment on it. Sometimes it's good. It depends what you want to achieve. It's very good to find individual problems if you look at a specific system. But if you have a global problem, you will not pick up on it. If your inverter, for example, if you have a central inverter and it's shutting down too early or whatever it does on a bad day, then you will not figure it out because all your clusters behaving sort of similarly. But in a larger system, to identify problems between elements of the system, and the smaller your cluster size is, the better. The lower the number of false positives you will get, so the cheaper your monitoring is, and that is actually what we're after. So it's one element of a good monitoring strategy.
Cool, thank you. Elena, please.
Yes, just to say that Ralph is right. When you have like a global issue, and then you're actually comparing your clusters, or then you won't be able to find the issue. But if you have an objective model adjusted, unless you have it from the beginning of your site for some reason, then okay, it's a whole new can of worms. But if you have an objective model and adjusted for each one of your clusters, let's say, then then you would be able, let's say, to pick out the issue because all of them would deviate from that model. But yes, comparing its cluster to one another based on PR, that would definitely not help in that case. That's true.
Okay, thank you for this further clarification. Okay, so I don't see any further questions in the chat from our audience. I'm feeling in a very agile phase of my life, so I suppose we can give a good 14 minutes back to people and call it a day, unless any of you has some final remark. Oops, sorry, we have a question from Lloyd Gorman. Thank you, Lloyd. How many sensors would you recommend per megawatt or hectare?
That's yeah, good question. It will depend on the project, but I'd go for double the amount that there is a minimum at the moment in IEC for some reason. I always want to have a check, an actual and a check pyranometer at the same area. So simple as that, but then that doubles the cost. And then it goes down to the question, do you use reference cells instead of pyranometers?
Oh.
Yeah.
Thank you, Elena. Okay, last call for any questions. I see none coming through. So with this, I would like to thank you guys for participating to this panel and sharing your experience and expertise and coping with my question for the past, well, 60 minutes or so. Thank you very much for your presentation and thank you for all of the work you have done for the publication of the guidelines and the review of the guidelines that is currently ongoing. And thank you to the audience that has patiently listened to us for the past hour or so. There are 2 upcoming sessions that you will see a slide on the screen indicating the time and the title of the 2 sessions that SolarPower Europe has been organizing, and we would very much encourage you to listen to those 2. And other than that, for me, is have a lovely afternoon and hopefully enjoy summer.
Thank you, Adele.
Thank you, Adele. Thank you, everyone.
Thank you all.
Very interesting conversation.
Yep.